Thank you very much for joining me. My name is Dr. Derek Wright. I'm an electrical engineer and I'm the MapleSim product manager here at Maplesoft. And today I want to talk to you about bringing theory to life with MapleSim. There's a number of challenges to engineering education. These challenges are increasing, and I want to talk to you about some ways we can get around these challenges. The first is that there's an increasing class size and decreasing funding. This means you're always trying to leave a similar impact to a larger number of students at the same time. This is very difficult to achieve. There's an ever-widening gap in math and science education from high school to first year. The demands on students in first year are increasing, while what's expected of high schools is decreasing, and this is posing an increasing problem to professors. Shortening student attention span, heavy demands on instructor time, and an increasing breadth of expectation for student results. Finally, keeping curricular materials up to date with technology and industry requirements is extremely difficult. Typically what happens is you take your course from last year and you deliver the exact same thing again. And as we all know, industry is pushing harder and harder on universities and colleges to make sure that their graduates are on par with their expectations. So this makes it very difficult to keep your curriculum up to date. The other fundamental problem is that what students learn and what they end up doing in reality, there's a huge disconnect between those two, and physical modeling brings that theory to life. It moves from equations in theory and connects that to applications that they're going to experience in their careers. And it does this in a way that does not discard rigor. It does this in a way that connects that theory and that rigor to the actual application domain. So I want to talk to you a little bit more about what physical modeling is and how we can bring that to the table. Looking at the Maplesoft suite of engineering products, they are all anchored around Maple, which is our flagship product. It's our symbolic and numeric computation engine that's been around for nearly 30 years and has a wonderful legacy, and I'm sure most of you have heard of Maple before. Sitting on top of Maple, we have MapleSim, our physical modeling and simulation platform, MapleTA, that's for testing and assessment, and MapleNet for deploying solutions online. And then finally, there's a number of additional toolboxes and add-ons that help to add to the educational portfolio. What I want to talk to you about today is MapleSim and Maple and what that can bring to the engineering curriculum that's really quite exciting and new. MapleSim is fundamentally unique from other tools in this space. It's fast, intuitive development of physical models. So that's a model based on the physics that govern the system. It allows you to tackle multi-domain systems in one environment. So what I mean by that is electric circuits, mechanical systems, thermal, hydraulic, multi-body, all in one environment. So the walls between domains are suddenly gone, and this is what industry is expecting. It leverages Maple for extensive analytical tools. So you have the entire Maple programming language and backend to analyze your models. Again, bringing that theory to life, bringing the rigor to the solution. And those system level equations are easily available to instructors and students. So now you can show what you develop in the software analytically matches what you've learned in class. Furthermore, you can apply the kind of analytical techniques you learn in school that aren't always available in the numerical solutions graduates are using out in industry. Focusing strictly on electrical engineering in MapleSim, MapleSim certainly has a comprehensive electrical engineering domain. So it's very easy to take electrical engineering concepts, bring them to life, and expose them to both the rigor and the results, and to put it in the context of something a little more exciting than here's a low-pass filter, here's an LRC circuit. Now we can start to talk about, well, how does this affect an active damping system, for example? The other really exciting thing about MapleSim is, again, because it's based on equations and not just numerical routines, you can start to do exciting things. For example, here's a second-order filter, something students would be familiar with that they would learn about probably in a second or third year circuits course. You can take that second-order circuit and you could easily turn that into a fourth-order circuit by coupling two of them back to back. You can show students that we make approximations in class in order to speed up computation, but with a couple clicks in MapleSim, you can actually get that parametric transfer function and show how two second-order filters truly give you a fourth-order response. and what determines that fourth order response. It's really exciting to be able to take something like that and instantly get a Laplace domain solution that means something, and it certainly means something for the instructor. It gives them a platform to talk about in class, a tool to use to convey ideas to the students. MapleSim and Maple really are educational tools for the next generation of engineers. You can bring theory to life without sacrificing rigor. You can quickly test the understanding of concepts and techniques. You can deliver in-depth coverage for controls, dynamics, engineering modeling, robotics, mechatronics, machine design. And finally, to respond to emerging trends in industry. So obviously the goal of a professor is to convey a certain core set of ideas, but those ideas become very engaging for the students and leave a much bigger impact when they're connected to the systems that they're going to encounter out in industry. This is what industry expects as well, is that an electrical engineer is going to understand not just how to do his or her job, but how that fits into the overall context of the system. Thank you very much for watching this presentation, and we'd be happy to follow up with any specific questions you may have.